It's fairly common for most people to have a house plant. Right here is my personal poinsettia plant that I definitely go through varying degrees of good and poor care, from watering to light and temperature control. What you see before you is the full desktop bench test setup for our Raspberry Pi and fully assembled project prototype breadboard assembly, as well to our left right here we have our test samples. As you can see, we utilized the full Raspbian operating system loaded onto our Raspberry Pi to not only test but develop our project. Here, what you see before is our fully assembled project prototype. As you can see, first we have the ADS115 analog to digital converter used for our project. We also have the ECE554 I2C temperature and humidity sensor. We also have an analog light sensor that is connected to one of the channels for the analog to digital converter. Secondly, our other sensor is the soil moisture analog sensor that is also connected to the analog to digital converter. These are connected to the I2C voltage and ground pins of our Raspberry Pi 4. What you see before you is the hardware output representation by simple LEDs connected to GPIO pins to the Raspberry Pi 4. The yellow LED represents the water pump actuation hardware output. The red pin represents the fan actuation hardware output. And the green LED at the very right represents the lamp hardware output representation. As you can see, the output is continuously running in a round-robin fashion as described in our presentation. Some of the key variables such as relative humidity, air temperature, and soil moisture percentage are being outputted so that the user may know what the actual values are. Furthermore, the output commands are also being displayed that correspond appropriately with the hardware output LEDs turning on. It should be noted that the threshold values in which the three hardware mitigation outputs, lamp, fan, and pump, all three are calibratable and can be chosen to fit the appropriate houseplant product, as a variety of plants will have varying degrees of needs. Now to demonstrate soil sample number 1, the dry sample. We have inserted the soil moisture sensor inside the sample and have the program running, as you can see. You can see that the soil moisture percentage is at a very low 2.4%. And furthermore, you can also see that the pump command is actuated on. The pump command being turned on is also visible in the hardware output. As you can see, the yellow LED represented right here for the pump is turned on appropriately for the dry soil sample with the low soil moisture reading. For sample number 2 with moderate soil moisture soil moisture percentage reading, you can observe that the soil moisture percentage is about 45%. And furthermore, the pump command is also still commanded on. Again, in the hardware output, you can see that the yellow LED is still turned on as the water content for the soil moisture is still low. Now for a third sample with very high water content, reading inserted with the soil moisture sensor, you can see that the soil moisture percentage is now at 73% for the terminal output. you can see that the LED, yellow LED representing that the pump has turned off appropriately as the soil moisture sensor is reading a high soil moisture percentage value. Again, this is also observed in the pump command output being 0. Lastly, sample number 4 is the water. Compared to earlier, the far left yellow LED has turned off appropriately. It has indicated that the water pump should not be turned on as the soil moisture reading is adequately watered enough. Next, in order to demonstrate the functionality of the lamp and fan outputs, the following 2 calibration variables must be explained. The first calibration value in question is shown in line 41. This indicates that if the relative air humidity percentage is greater than the calibration value set at 15%, then the mitigation action where the fan will turn on. Similarly, for temperature, if the air temperature reading in degrees Celsius is less than this calibration value set to 25, then the heat lamp will turn on to take mitigation action. This can be observed with our system running with the terminal outputs. As you can see, the air temperature reading is 20 degrees Celsius, which is less than the calibration value set at 25. This means that the fan command will be outputted appropriately. Secondly, the relative humidity is read to be about 30%. Again, this is greater than the humidity threshold calibration set to 15. This means that we expect both the lamp and the fan commands to be outputted. These are also observed in our physical hardware with the following 2 LEDs, the red and the green, turned on. It should be noted that the calibration values for relative humidity and environmental air temperature were set to extreme values for the sake of demonstrating the functionality of the feature, and would actually be changed to appropriate values that would be optimal for plant growth health. This concludes a brief demonstration of our ECE554 auto-grow tomato plant monitoring and care embedded system project. Thank you.